Name will be used to split data. That is to say, the partition does not support all field types. We currently support string type and number types like int, bigint, decimal, etc. There is also a date type. We do not support a type like GID. If the first field in this component is GID, it does not support it and will choose the second field and split it. So we suggest that in daily use, you'd better not set the partition column if the component setting of your table is not particularly strange. That is, do not set this parameter. Let SeaTunnel automatically select the component and index to split. Okay, below are some parameters related to the splitting. Split size means, for example, how many rows. There are 10 million rows in my table. I can set this value to 100,000. Then it will distribute a partition per 100,000 rows. But this is not absolute, because when we are calculating the number of rows, there is a miscalculation. Then when we are splitting, there is also a miscalculation when calculating the range of distribution. But we will try our best to get closer to the value. Below are something about the distribution algorithm. For example, if we want to calculate the distribution, I want to calculate the distribution of the ID component in the table. That is, the distribution of the component. What is its maximum value and minimum value? How about its overall distribution? You can go to the source code in detail, or we will talk about this later. Then these parameters are used together. I will set a partition column. At the same time, I will use these two parameters to control similar external conditions. But now, these parameters are not recommended to be used. And leave the partition column unset. You only need to configure the split size. But this can also be a default value. The default value of the new version should be 100,000. This can also be kept as default. In fact, many times we don't need to pay attention to the distribution strategy. We just need to ensure that the table has a component. If there is no component and the unique index in the table, we can specify the partition column and unit to split. But this is generally inefficient. Of course, there will be some tips here. If your table cannot be splitted, for example, you have no component and no unique index, and the parameter does not have a configuration, then the entire partition is actually a single partition. If we use table path to replace the query, then we actually try to use the table list to configure. This is my suggestion. Because in the early version, in the GDC directory, we used query to configure the table I read, but later we used table path to configure it. We suggest that the old query method should not be used anymore, unless I need to choose a format. For example, I don't need to synchronize all the formats in the table. I only need to synchronize a few formats. I can use query if all the formats in the table need to be synchronized. We recommend using table path first. Don't use query to synchronize. If I want to synchronize multiple tables, then we need to use table list. There are some examples below. I give some examples according to different characteristics. For example, if I use partition column to make a partition, then we can set a partition column like ID, query, partition column, and split size, for example, 10,000. The second method is to make a partition through the main key, or the only key. In fact, we can see that we only need to use split size. Of course, we can use the default value. We don't need to configure anything. Then it will automatically go to your table path to get our main key information. If we only write query instead of table path, while there are some complex skulls in the query, the program cannot automatically judge what your main key and the only key are. At this time, it cannot split. So if you want to use the partition properly, we recommend that you write table path without using query. It can be simple to write a query, for example, with the new form that doesn't contain John, or concept of multiple tables, or complex external conditions, or something like that. Don't show up in the skull. Otherwise, the main key and the only key can't be identified. The following example is a multi-table reading. The difference between a multi-table read is that we have to use table list. In table list, it is an object element. Then in each element, a table path can be used. For example, we use table path to read the table 1 in test. Then another one, we use table path to read the table 2 in test. But I only read a few of the segments in it. I have to add a while condition. Then I can use the select ID name from this table. Okay, it is best to write both of these, because after writing this, we can automatically identify the main key of the table. If we don't write them and only use the query, it is difficult to do that. The following are some parameters. I have introduced them to you before. Now, let's go to the trial. In this example, we will use a configuration of GDC MySQL source. I suggest you to try to copy it. Don't type these words. It is easy to make mistakes. Copy it. Put it in a file. Change the path to 1. Then here, I have to change to my own library. I have prepared data, source, 1 and data, new. The library is called CASource. Okay. Then use the name and password. Here, I have to update 2 tables. I found these 2 tables. Okay. This is the table. The table name is CASource. The table name is this. The other table name is also CASource. The table name is this table. But this table has a lot of files. I don't need to upload all the files. I can pick some files from here. For example, I will pick an ID file. Then there is a file called fint. Then I will pick another one. A data type. I don't need this. Through this, I have prepared it. I have to synchronize the 2 tables in MySQL. Now, I will test the source first. Is it the correct one? Then I will use a console for sync. Copy it. Okay. Then run it here. You can see that the synchronization has been done. I synchronized a volume of 2,293 data. Then the task is successful. At least this shows that there is no problem with the configuration of our source. Next, let's sync. We need to synchronize the sync to our Doris. So we need to look at a folder of our Doris sync. The Doris folder actually contains the support version, the support engine, and some key features. It can ensure exactly once, and also support the sync of the upper end CDC. Next are some parameters of Doris sync. Here we need to configure its FE node. Widget is an IP plus terminal. This is a GDC terminal. When we enable to PC, we need to specify a. In fact, Doris needs to specify a label for each batch of input data, then our label will be specified. Then Doris will use this prefix to generate a label. Then it will ensure the sync of our data and the sync of our to PC data. This is very important. It must be set. Next is about whether it is allowed to delete. This is also used in the CDC sync scenario. For example, in the upper end CDC, there is a delete data in MySQL. Only when this is set will Doris actually delete the data. If this is false, Doris will not delete this data. Here is some information like, I will not introduce it in detail. If you are interested, you can go further to it. Then I will introduce 2.3. For new features. The first one is called Schema Save Model. Schema Save Model's main function is, when I want to do some kind of operation, it supports three things. The first one is recreate schema. When I check that there exits the specific table in the target end, and I want to delete and rebuild the table. Where does this table name come from? One way to show the table name is that I can directly specify the table name at the sync end. I will introduce it to you later. Another way is to take the table name in MySQL. Then it will check if there is the table named table1. Exits in Doris. If it does, it will delete and rebuild. The second option is when the table exists. I just use this table. When the table does not exist, then I will create this table. It will automatically build the table when the table does not exist. The last option is that no matter the table exists or not, I will report it directly. It will report error directly. This means that I need people to control everything. I need my users to know that I cannot automatically build the table or do some automatic operations. This is the table structure automatically built. Where does the table automatically built table structure come from? Where does the skull statement comes from? They come from the features of the newly added catalog and the features of table converter. In 2.3.4 version, the source will read the table structure and store it in the catalog. Then it will be transferred to the bottom, the sync end. The sync end is based on the table structure information in the catalog, including the length, the type, and the accuracy. Then it will automatically convert to the table structure of my target end, and the type, etc. Next is the data save mode. This is mainly about how to deal with the data in the target end. What should I do before I start my work? This is very similar to the concept of pre-skull. The first option is to drop data. As soon as I start a task, I need to clear the data in the target table first, and then synchronize it. The second option is to open the data. I don't care about the data in the target table. I just need to continue writing in it. The third option is when the first two options are not to your demand. We can support self-definition. The self-definition is used when we can use a custom skull to specify the data in the target table. Here it is, custom skull. I can write a Doris skull to deal with the data in my target table. The last option is that when the data is in the target table, I report error and stop the task. Stop synchronizing. This is the data save mode. The next parameter is for Doris.